Welcome to the last chapter of chapter 10 in Pure 1, where we have gone through a journey of working on a class diagram and learning new identity trick identities. Okay, so as literally a true chapter coming up from GCSE that is new from it. So in this last bit, we're looking into equation identities where we're mixing the identities with the class diagram. Okay, so you'll need to be able to solve quadratics which involved trigonometry and trigonometric identities. So, quick recap, you've learned two new identities. So 10, let's not use theta, let's use A. 10A equals sine A over cos A. These are not given in formula booklet. Also, sine squared A plus cos squared A equals 1. Okay, if you want to be straight, be straight, it has to be triple equal because they're equivalent. Anyway, it doesn't matter. So the steps to solve trigonometric quadratics. First step, use identities when situation arises to convert into only one trig ratio to solve quadratic normally. And 3, use class diagram to work out all solutions. So when you use class diagram, you use it, use it as soon as you do inverse sine, inverse cos, and inverse tan. So my handwriting is really ugly, I know. I'm working on it. Just kidding, I never work on it. Use it as soon as inverse sine, inverse cos, inverse tan. So example in here, 5 sine squared plus 3 sine x minus 2 equals 0 in the interval between 0 and 360. Now there are only one trig ratio, so in here you can use the quadratic formula or use a calculator straight away. So this is actually a quadratic. It's called disguised quadratic, which you've learned in chapter 2 of Pure 1. But in here, if you want an extra step, you can write let y, equals sine x, because there's a quadratic. So if we let y to be sine x, you can see 5 sine squared x becomes 5y squared, plus 3y minus 2 equals 0. The y is really ugly as well. It doesn't look like y. It looks like a fly dancing, a ugly spider dancing. Anyway, dancing maybe? 5y squared plus 3y minus 2 equals 0. So use a calculator. Again, in A-level maths, especially Edexcel, you don't get any marks for showing how to solve a quadratic. So you use a calculator because they will expect you to use a calculator function to solve it. So you should get y equals to 2/5 or y equals to minus 1. But it was never about y from the get-go because it was about sine x. So we can now replace y with sine x. Okay. Now, if you actually see it as a quadratic from the beginning, you don't have to show the y something like this. You can just go from here, this step, to this step. Okay, right, just for saying. And then sine x equals 2/5. So then we have two questions to do. So x equals inverse sine of 2/5. Or, x equals inverse sine of minus 1. Now, this one, we use class diagram. Okay, for this one, we use class. Let me use different color. So we use class diagram for this one. Because inverse sine of 2/5, you get two answers. But what about minus 1? Now, if you put inverse sine of minus 1 in the calculator, you'll get negative 90 degree. What you realize is when it comes to negative 90 degree, it's not a very nice number to use class diagram because minus 90 degree is exactly on the line of the axis. How do you do class diagram on this? So you can't. So what can we do when it comes to minus 1 or 0? We use the sine graph. Okay, so let's do the sine graph quickly because that one is easier. So let's do that. So sine x is that right? So when the sine equals minus 1, 270 degree. So from here, so we know x equals 270. Or minus 90, but minus 90 is out of range, so we can cross it out. So x equals 270 is the only answer that is valid between 0 to 360 degree. Okay, what about inverse sine of 2/5? So you should have done that a lot in the previous chapter. So if you do inverse sine of 2/5, you should get 23.6 degrees. So 23.6 degree. You can do the mental class diagram. So 23.6 degree to reflect in the sine quadrant because sine is positive. So in here, 23.6. This value is same as 180 degree minus 23.6. So 180 minus that is 156.4 degree. So 156.4. So x equals to 23.6 degree or 156.4 degree. As a good gesture, we can just write the final answer as group them all together, 23.6 degree, 156.4 degree, or 270 degree. Write them in one line. Okay. But let's say you forgot to include one of the answers in the final answer, but you actually wrote it in some way in your working out. Don't worry, you will still get marks for it. Okay. So just writing this down really helps the examiner to read your final answer. All right. So that's it. Quadratics in a trigonometry equation. All right. Next one. Solve sine squared theta minus 30 degree equals a half. So what does sine squared, the square here means again? Now the square here actually means sine theta minus 30 degree. Oops. Whole thing squared equals a half. Now why don't we put a square? Why don't we put a square behind the angle? Because it looks like because the square inside the sine means you do sine theta minus 30 degree times sine theta minus 30 degree. But if you put a square at the back, then it looks like you're just squaring the angle, which is incorrect. So in here, if I want to square it, if I want to get a squared, I have square root. So square root, when I have square root, I have plus and minus a half. Now, when I do trigonometry equation with plus and minus a half, my personal habit is to write it out as root a half or write another one. Okay, another one, negative root a half. Okay, so write as two equations so I can see it's like two separate questions to do. Okay, so in here, I need to, in order to solve for theta, I need to do inverse sine on the right hand side. So theta minus 30 degree equals inverse sine of square root of a half. Put in the calculator, that's 45 degree. Okay, so 45 degree. So we can use a cast diagram. Remember, as soon as we inverse sine, we're going to cast diagram. Sine 45 degree. Okay, for sine to be positive, has to be here as well. Okay, so therefore from this one, we can tell theta minus 30 degree equals to 45 degree or 135 degree. Now for this one, because it's negative version, okay, you can do a new cast diagram, which I'm going to do in here for you. So if you do inverse sine of negative 1 over root 2, you get negative 45 degree. Negative 45 degree is the same as here. For sine to be negative, reflects in here. Okay, therefore, theta minus 30 degree equals, go that way, which is 225 degree. I try to rectify it, but that's 225 degree or 315 degree. Okay, now, because there's a plus and minus, to be honest, you could do it with one cast diagram. How? Well, let's say do a new one, okay? From here, okay, if I do a new cast diagram, I get 45 degree, okay? That's a positive value, 45 and positive 5. But we know these two values, these two quadrants, we don't reflect in these two quadrants in this one, the left hand side, because sine was positive. But we can reflect in here because we also need negative values. So the purple ones are for the positive value, but if you reflect in here, you can see we've got the negative values in here as well. So you can use one cast diagram if that makes sense. But if you have no idea what I'm talking about, just do two separate cast diagram. Also, one more thing. You don't get any marks for showing your cast diagram. What it matters is these cast diagram are just a method for you to work out these values. Some people like to use a sine graph. Some people like to remember the formula for that. If you don't know, there's some formula people can remember about 180 degree plus and minus angle for sine. I think 360 minus plus and minus for cos. If you know what I'm talking about, you will know. If you don't, ignore it. Okay, so cast diagram is just one of the three methods you can work out different angles. Right. Anyway, so in here to work out the final answer, we're not done yet. We need to find theta. So add 30 degrees to all the values. So 165 at 30, 255 and 345 degree. And let me check the range. Yep, 0, 360. These are the answers. Okay. Right, if you're happy with this, pause the video, have a go at the question. When you're ready for the answer, you can press play. This is the final answer. Okay, 4 answers, 4 values. So you can let y to be cos theta. This optional again. If you don't have y equals cos theta, your next line should be this right away. Okay, and then you get 2 values. 2 values do cast diagram. Okay, for both of them. 6 degree, 300, 101.5, or 258.4. If you're struggling with cast diagram, I would suggest you go back to the video, I think 10.1 or 10.2, chapter 10.1, 10.2, which I explain in details how we do cast diagram. Okay, right. Example, moving on. Now this time you can see in this equation, okay, there's a square, but there's a cos and there's a sine. We can't solve an equation with both cos and sine because usually we can make sine and cos into a tan. if you have no idea what I'm talking about, okay, I think in the previous ones like this one, with sine and cos, you can pause video, have a read through again. To make a 10, we can divide both sides by cos x, make a 10x. However, we can't do it in here because if you divide everything by cos squared x, this you can try it on a separate piece of paper. You can try it, divide everything by cos squared x. You feel like you will notice there is extra 1 over cos theta dangling in there. So we can't do that. So what can we do in here? Use identity because we can make cos squared into sine squared. We can see that's sine. So might as well make this in a sine. You know, peer pressure. They're all sine. Do a sine. Just cos. It's a lame joke. Right. So I want to make this into sine. So change this into sine squared. So change into sine. Okay, into sine using sine squared using identity. Okay, so 2 cos squared. So remember, sine squared A plus cos squared A equals 1. So cos squared A equals 1 minus sine squared A. So we can replace the 2 cos x into 2 cos squared into 1 minus sine squared A. Oh, no, it's not A because we say x in here. So what I've done is I have just changed this. Cos squared, replace this one, cos squared. Plus our 9 sine x equal 3 sine squared x. Okay, expand the bracket. 2 minus 2 sine squared x plus 9 sine x equal 3 sine squared x. Hopefully by now in here, you should see quite obvious. We can rearrange it to make it into one nice quadratic equation. I'll bring everything right inside because that will give us a positive x squared term. So 5 sine squared x minus 9 sine x minus 2. Okay, one more thing. A lot of students will write the 2 and the 3 or the 3 and the 5. S, very similar, like 3, that's a 3. That's a S, that's a 5. You know, they're very similar. So 3, if you scribble it, it looks like 5 somehow. It happens a lot. Happens to me. Happens to a lot of students. So in here, I can use quadratic formula, calculator. So polynomial, degree 2, 5 minus 9 minus 2. So I get sine x equals to minus 2 or, wait, have I got it wrong? Minus 2, hang on, 5x squared minus 9x minus 2. So it's 2. Oh, sorry, hang on. I put it in the calculator wrong. It's 2 or sine x equals to a fifth, minus a fifth. Sine x cannot equals to 2. We can reject this. Now, if you try inverse sine of 2, if you try do inverse sine of 2, you get math error. Simple, because sine x is bound between 1 and minus 1. So you can't get any value bigger than 1 or minus 1 for sine x. All right? So for sine x equals minus 1/5. So let's do inverse sine of minus 1/5. So inverse sine of minus 1/5 is negative 11.5 degree. So negative 11.5 is here. For sine to be negative, we should reflect in the 10 quadrant in here. So x equals to, if you go clockwise direction, that's 180 plus 11.5, that's 191.5 degree. Or go this way, 360 minus 11.5, which is 348.5 degree. Let's check the initial question. The range is between 180 to minus 180. So this is out of range. So we found the principal solutions. Let's subtract 360 of both of them. Actually, both of them are out of range. So let's minus 360 of both of them. 191.5 minus 360 is minus 168.5. We can accept that. 348.5 minus 360 is at negative 11.5 degrees. So we can accept these two, both cross out the original two. Yet the principal solutions are both of them. We can't accept it. Okay, so these two are the answers, are the only valid answers. All right. So, but the main thing about this example is all about changing the cos squared into sine squared. Now you might be thinking, why can't we do sine squared into cos squared? Reason being is because if we change it in cos squared, what about this one? What about the sine x? The identity is only for sine squared and cos squared. So you can usually tell using this one here, the sine x. That means we will change everything to sine. Okay. All right. So, or you can see which one has a bigger majority, I guess, and change cos squared into sine squared. Okay, if you're happy with this, pause the video, have a go at these two questions. Practice question two. Okay, pause the video for A and B. For A first, if you got it right, they can move on to B. So pause the video and work out on A. When you're ready for the answer for question A, you can press play. Okay, turns out part A is actually quite easy. So here's the answer for part A: 60 degree, 300 degree. We have to reject this because it gives you math error. Now, you don't have to explain why you reject it. Math error, reject it. But if they ask you, you can say because the range of cos is bound between 1 and -1. So 2 is out of range. Question B. If you've done question B, here are the final answers. Okay, if you check it, I did not show any working out. If you got it right, just move on to the exam practice. And and then if you haven't done it part B yet, have a go. When you're ready for the answer, you can press play. Here's the workout for part B. Okay, so change the sine squared into 1 minus cos squared. This time you can see cos theta, so we'll change it to cos squared. This becomes a quadratic. And then we can put in a calculator to solve the quadratic for us. You should get a quarter or 0.5. Actually, let me double check the answer. So -8, 6, and -1. Yeah, a half and a quarter. Yep, that's right. Okay, so then you use cast diagram for both of them. For left hand side, I've done it. For the second one, it's actually the same as part A. Okay, so in total, 4 answers. Right. So last but not least, uh, oh, where's the exam question gone? Right, a little technical error. I think I moved the page upwards somewhere. Found it. So now have a go at the exam practice. Okay. Pause the video, show that the equation can be written. Sorry about the format in here. It was meant to be in the middle, but when I screenshot it or when I print out, when I export the PDF, somehow they shift backwards to the left. But this should be right in the middle. It will basically show the equation 5 sine x equals 1 plus 2 cos x squared could be written in this form. Okay. Pause video for both a question. When you're ready for the answer, you can press play. So here's the final answer. Okay, question A, you can see in the final written form, there's no cos squared. So that's a cue for us. That's a hint for us to change cos squared into 1 minus sine squared. Bring everything on one side, and you get the answer. Okay, oh, -3. Make a silly mistake. Silly mistake. You know, this happened to you, happens to me, happens to everyone. But we need to try to minimize it. Puppy. Solve for that one, quite easy. If you when you solve, put in quadratic formula, put it calculate, you get sine x equals -3, cross it out. I think there's 1 mark for that. And then inverse sine half, cast diagram. If you don't know what cast diagram by now, you should really go back to watch the video from the beginning, 10.1. Okay, so that's the end of the chapter 10.